Welcome. Today's notes worksheet is entitled Synthetic Division. We're going to be working on some division with polynomials here today, and it's time to take a look at a shortcut way to pull that operation off under a very specific condition, and we'll talk about that condition as we go through this lesson. So why don't we do just a couple of question and answers here initially, and then a little investigation, and then now we can kind of put this synthetic division to the test. So let's start it out. At the top it says, is 5 a factor of 24? So just trying to start out nice and concrete for you. Is 5 a factor of 24? I'm hoping you would answer no to that. And then there is a follow-up question to that, and then we can kind of get into the generalities. But basically, what are the factors of 24? And if you don't mind, take a moment and list a few of those for me just to get a sense of it. And then obviously we'll put it in place as our definition. So 5 is not a factor. I think we can all be pretty safe in that. Let's go ahead and put this in. So 1 is a factor of 24, 2 is a factor of 24, 3 is a factor, 4 is a factor, 6 is a factor, 8, about 12, about 24. And we can kind of stop right there. So why are these factors of 24 and 5 is not? Obviously, that kind of gets into this last question right here, and really one of the primary objectives of today's lesson is dealing with factors. So what is a factor? You know, you could paraphrase me if you'd like, but I'm hoping you'd all agree it has to be something that divides evenly into our term. So a value that divides evenly into the term. Whatever it may be, concrete, abstract, makes no difference. So 2 divides evenly into 24. 5 does not divide evenly into 24. There's a numerical value other than 0 that's a remainder. All right, good. So we did this a long time ago. We talked about some long division with polynomials, and we're going to go ahead and do that momentarily. At least I'm going to do that momentarily. And then we're going to kind of see how that relates to the synthetic division, this new form of division that we're going to take a look at, which should offer us a nice shortcut here. And we're going to do a lot of work with synthetic division over this next unit. So this is a little skill set that you're going to want to make perfect and quick and efficient and all that good stuff. So you can pretty much just drop your pencils and just quickly watch and listen. I'll do the work up here. But basically, I'm going to perform this operation, this into this with long division, going to time myself, then I'm going to do the same thing with synthetic division and time myself. So I'm going to get myself set up here. I'm going to do this right on my board. How many times does x minus 1 go into x cubed minus 3x squared minus 10x and plus the 24? All right, so something like that. I'm going to gear up here momentarily, kind of think things through. So I'm looking for the quotient remainder with long division, and I'm going to start right now. X goes into x cubed, x squared times, I multiply it on down, and I get that piece right there. Minus out in front, these cancel, and I get minus 2x squared minus 10x plus 24. Okay, x goes into negative 2x squared, minus 2x times, multiply it on down, get negative 2x squared plus 2x. Subtract on down, negative 12x plus 24. And one more time, x goes into negative 12x, negative 12 times, and I get negative 12x. And I get a positive 12 right there, minus out in front, 12, stop. Ooh, okay, so I think it took me, I'm seeing about 42 seconds. Yikes, that was a little slow. That's all right, though. So about 42 seconds to kind of pull that off. Might have been a little less. I lost track of the time there, but we'll go with 42 seconds. So just to recap, how many times does x minus 1 go into this dividend right here? It goes in x squared minus 2x minus 12 times, and the remainder is 12. All right, good. Now, guys, let's go do some synthetic division. So synthetic division is going to be a more efficient, compact, quick way to do the identical operation. So let me just get myself set up. If you've seen this before and you've set it up in a slightly different fashion, that's okay. This is just how I kind of set it up here. kind of a backwards L for our dividend. Here's our x minus 1, by the way. And here's our dividend running on through, just the coefficients. 1x cubed minus 3x squared minus 10x plus the 24. So I'm going to breathe for a second and then go get this one right here, synthetic division, and then we'll kind of just look at them side by side for a moment. So here we go. On your mark, get set, and go. So bring down the 1, 1 times 1, get that right there, get that right there. Got that, negative 12 and 12. Stop. And a little slow, but still not bad. 10 seconds. The exact same operation, the exact same result, and look at that, just a very small fraction of the time. So if you're kind of wondering where the answer was, look at this quotient right here, and look at the numbers that I put right down here. And do you see this as the 1x squared? Here's the minus 2x. Here's the minus 12. I put a little curtain here. I like doing that. This number right here on the back end, do you see what it relates to? And that would be your remainder of 12. And there you have it. So just a couple things to note as to how this is going to play out. This, again, and I almost kind of need my hands and for you to see my hands on this, but I'll do the best I can with this. As you can see, it's a very compact, efficient way to pull this operation off right here. So if you kind of take a look at a couple things, does everyone kind of see the negative 3, the 1, and the negative 2 kind of right in here? That's this piece. And in the next level, do you see it's kind of more compact? There it is, just right there. And do you see the 24, 12, and 12 right here? Again, kind of giving us those values. One main difference, and then we'll kind of get going on this. Do you notice my divisor was x minus 1? Yet I used a value right here in my synthetic division of positive 1. That is the case. We're always going to kind of do that opposite piece. And one of the objectives, one of the purposes of doing synthetic division is finding zeros. And when I have something like this right here, what's the 0 that comes from x minus 1? It's positive 1. And that's the number we're going to use. So we're going to use the number that comes from the, quote, 0 of that divisor. Okay? So anyway, x minus 1, we used positive 1. One other major contrast here, what operation have we always done with long division on the outside? Minus. And that's what I did here and here and here, as I showed you, matching up with these pieces. But in this case, I didn't do, if you look at what my operation, I did not do subtraction as I worked vertically. What operation did I do with these two to get this? I did addition. And of course, the reasons kind of go hand in hand here. Instead of x minus 1, I used positive 1. So I used the opposite in the divisor, and so as a result, I needed to compensate for that and do the opposite operation going down. Instead of subtraction, I do addition. Okay, and that's how it's basically going to play out. It's going to be that quick. You know, 10 seconds is actually fairly slow. So you're going to do better. Here we go. So synthetic division, as it says, is a compact, efficient, and quick way to perform division with polynomials, and here's the key, underline that for me, if the divisor is linear in nature and just either x minus or x plus, obviously, x minus that constant. All right, so that's the condition that we're going to be working on. By the way, is x minus 1 a factor of that cubic polynomial right there? No, I think we had 12 units left over, if I remember correctly. So unfortunately, it was not a factor. Remember this property way back when, you know how multiplication and division work? That dividend is made up of the quotient and divisor multiplied together plus the remainder. So if you kind of look at this piece, and let's put this in if we can, because I kind of like making the connections here and to where it's going to head. So that dividend was made up of the x minus 1 times that quotient, x squared minus 2x minus 12, and then plus the 12. If I had you do a little polynomial multiplication right here and then add the 12 at the end, you would get this piece right here. Sounds good. All right. Well, let's go try it out a little bit, just some practice on this, and kind of show you at least where it's headed, but we're really going to hit the ground running on this next unit when we pick it up. So here we go. Example 1, perform the operation. And by the way, it looks like I kept the same dividend there. And so divided by x plus 3, and then is x plus 3 a factor? So here's the idea. We're going to use negative 3 as our c value. You hear me use that phrase a lot, the c value. So negative 3 comes from x plus 3. So we're going to use negative 3 right there. And we're going to run the coefficients straight across, 1, negative 3, negative 10, and 24. And then I put my line right down there, and then we just do it. You'll hear me just repeat a particular mantra over the course of this operation here, and it's really not too bad. But here's how it goes. Add vertically and multiply diagonally. So maybe write that off to the side. I'll leave that totally up to you. But that's what I just keep repeating myself. Add vertically, multiply diagonally. Add vertically, multiply diagonally, until you get to the end. So here's how it does play out. Let's get comfortable with the algorithm here. So initially, everyone, whatever number this is, it comes on down, and that's part of the add vertically. 1 plus 0 is just 1. And then here's the diagonal that I'm referring to. See, that's on a diagonal. So I multiply those numbers together, multiply diagonally, and it's going to go right here. So negative 3 times 1 is negative 3. Add vertically. Now I can get this going. And I just repeat, everyone. Multiply diagonally. So negative 6 times negative 3 is positive 18, and it goes right in there. Add vertically. And repeat one more time. Multiply diagonally. Here we go. Negative 3 times 8 is negative 24. I always separate the last number with just a little curtain, as that number does represent our remainder. So, how many times does x plus 3 go into that cubic dividend right there? Well, it goes in exactly 1x squared minus 6x plus 8 times. So, perform the operation. We did it. It looks great. X squared minus 6x, plus 8. And secondary question, of course, is x plus 3 a factor of that cubic? Absolutely. Because why? Well, it divided evenly into it. There was nothing left over. And let's go ahead and keep going on this. Just keep thinking out loud with this. I would just write this below if you get a chance. So using what we came up with above, basically what we have in this case is that dividend is made up of the divisor, x plus 3, times our quotient, which was that right there, plus whatever the remainder is, which happens to be 0. And so now you can see that this is truly a factor because this times this gives me that right there. It looks outstanding. And just kind of thinking in the future here where we're headed, could I maybe even go further and factor this, break this on down? And so as a result, can I find a way to write these big cubic polynomials in factored form? Yeah, absolutely. And that's what we're going to do. Cool. All right, let's jot a few more things down and keep it going. So the quotient when performing synthetic division happens to be what is called a depressed polynomial. And so I've done this instinctively without actually saying it, but essentially what happens is the quotient is always going to start out in terms of being the degree, 1 degree less than the dividend. So if I start out x cubed, the quotient is x squared. And that's what this piece is right here. The degree is 1 less than the degree of the dividend. So if I start out with the dividend that is like x to the 5th, then our quotient will start out x to the 4th. So the quotient is 1, the degree of the quotient is 1 less than the degree of the dividend. Wonderful. All right, let's go get 2. Good one here, by the way. Anyone think they know this piece? do I probably not want you to forget? Look at that dividend, everyone. What are you thinking here? Probably want some placeholders. Think that would be wise? And you do need placeholders all the way through. Even with long division, I totally recommend doing placeholders. This, you really have to. So here we go. Let's get it going. Our C value, everybody, is going to be +1 coming from here. So the C value is +1. And then we're going to run our coefficients of the dividend. I have a 1x cubed. I have a 0x squared. I have 0 x's. And I have -1 units. So don't forget placeholders. Even if it was on the back, we would need a placeholder. All the way through, from the starting value all the way down to the constant there. All right, so let's do this. A little faster now, maybe. Let's see if we can pull it off. Again, you could easily beat my 10-second time. That was slow, slow, slow. But here we go. Bring it down. The 1 comes down, multiply diagonally, and it goes right here. 1 times 1 is 1. Add vertically, multiply diagonally, answer goes here. 0 plus 1 is 1. Here we go, 1 times 1, little curtain, and there we go. So how many times did x minus 1 go into x cubed minus 1? It went in exactly x squared plus x plus 1 times. Exactly. Is x minus 1 a factor of x cubed minus 1? You bet. Could I write x cubed minus 1 as a product of these two things right here? Yeah. Now, one thing, and then we'll get right on to the back side there. I actually made you factor this a long, long time ago. This is what's called a difference of two cubes. This is a pattern that we looked at in terms of breaking it down into factors. And I don't know if you remember how it factored, but it factored into a linear times a quadratic. And if I had to follow that pattern from the beginning of the year, that's exactly how you'd break it down. And look, this times this essentially, or this times this. That gives you the x cubed minus 1. Pretty awesome. All right, I'm hoping you're starting to click with the synthetic division. Let's do maybe just one more, kind of all the way through. See at least a little context. But this next unit that's coming up, it's really the key skill set to be successful with it. It's an easy skill set, but it's key. And as I said, what we're looking for is quick and perfect. We obviously have to be very careful on the arithmetic mistakes. So let's try to avoid those. Here we go, guys. Example 3. Letter A. Given that x plus 4 is a factor of that cubic right there, find the other factors of the polynomial. All right. So I'm basically telling you that this is a factor, meaning this would divide evenly into that cubic right there. So what we're going to do is use that to see what the quotient would be, and then use our concept of division to break it down even further. So I'm going to start out my C value of -4, and guys, let's run those across. And let's see if you can pull it off here. I would love to see you break the 10-second barrier. Here we go. Bring down the 2. Multiply diagonally. Goes right here. Add vertically. Okay, multiply diagonally. Goes right here. Add vertically. Multiply diagonally. Add, and lo and behold, there it is. Remainder is 0, which again basically tells me that this divided evenly into that right there. And I'm hoping you would all agree that this, at this stage, is the quotient, 2x squared minus 3x plus 1. So what does that mean? Let's develop a little context for it. Basically, at this stage, the cubic is made up of x plus 4 times 2x squared minus 3x and plus 1. All right, sounds great. And so as a result, can we find the other two factors? Well, this times this is equal to the cubic. Can I take this quadratic and break it down into a product of its own two factors? Well, sure. And so A and B are going to go hand in hand here, basically. But let's see, x plus 4 is a factor, and then it just says find the other two. So why don't we do that right here? And let's go get them, guys. Let's just go quickly factor this. How about a 2x and an x? How about a 1 and a 1? How about minus minus? And there you have it. So if this times this equals the cubic, would these three factors multiplied together give us that cubic? Yeah, of course. And that's the idea. So find the other two. It looks like just 2x minus 1 and x minus 1. I guess there's some overlap in these questions here. So now let's think of that polynomial as a function. And remember, every polynomial can be expressed as a function here. And so this is nice. I've got f of x equals right here. Write the function in factored form. So we saw it in standard form. I told you that x plus 4 was one of the factors. We used that to see how many times it went into our cubic, and it went in this many times. And so as a result, this times this equals the cubic. And then, of course, guys, we broke that on down further. And so you see this piece right here. How does that look? So standard form, factored form. We'll talk a lot about that through the course of this next unit. One last piece, guys. I'll graph this, and we'll wrap this on up. So it says graph the function and determine its zeros. Nice. So I'm going to go ahead and bring this up right here and go to my y equals. You don't have to bother in this case. You'll be doing plenty of this in just a little while. So I have that right there, 5x squared and minus 11x. And last but not least, plus the 4. I'll zoom standard. And there we go. If I asked you to find the zeros, remember, real number zeros show up as x-intercepts. So 1, 2, 3, here's negative 4. There's a positive 1 right here. And then you can kind of see this one show up at positive 1/2 as well. So I think those are our 4. Negative 4, positive 1/2, and positive 1. And guys, if I asked you to go ahead and set those factors to 0, would you come up with those three numbers? Of course you would. And there you have it. Factors producing zeros. That's what we're going to be taking a look at. So long story short, and then we'll wrap this on up. We did a number of factoring patterns at the beginning of the year to break down polynomials in standard form. What we need is some ways to break down polynomials in standard form that where the traditional methods are just not satisfactory. And so this synthetic division is going to be that approach for us. All right, well, why don't we kind of wrap it up at that stage? Try this out, get a little practice with it, but again, quick, efficient, perfect. That's what it has to be. Hey, thanks for listening. Of course, guys, let me know if you have some questions.